All right, Gavin, we've had some technical issues today, so we're going to try to pick up where the first part of the video kind of broke off. I got the first part of the lesson and the last part of the lesson, so we're going to record the middle part of the lesson here without classmates in the room, I'm afraid. We were working on number 16, or about to work on number 16 when the video kind of cut out last time from the homework. Though if you're watching these sequentially, like, huh? Anyway, from the homework, number 16, should have identified the square root of 16's rational. That's just 4. And 3 times 4 is just 12. So there's my answer for number 16 on the homework. Number 18, 7 times the cube root of 648. It's like, man, that is a huge number. I don't actually want to go through thinking, I wonder what cube can fit. Now, I know 8 can fit, okay? I know that's divisible by 8, but I don't really want to do that, okay? I'd rather say, well, let's just try cutting the number in half, right? 324. Can you check the cube root of 324? Nope. Square root, yes. If this were a square root, I'd be in business, but it's not a square, it's a cube root. Okay, how about 3? Let's see. 2. Can I take the cube root of that? Yes, I can. So I'm going to rewrite this as 7 times the cube root of 216 times 3. Keep the 7, get a 6, keep the cube root of the 3, and we get 42 times the cube root of 3 for our answer. And then last of all, number 20, from the homework, 5 times the square root of 40. Believe we'd seen a cube root of 40 earlier in the homework, and we separated that into 8 times 5, because 8's a cube. This is a square root. I don't want 8 times 5. I want 4 times 10. To get 5 times 2 times the square root of 10, or in other words, 10 times the square root of 10. Our answer, number 20, on the homework. Hopefully, you did well with the homework, Gavin. Of course, let me know if you need some video tutoring, particularly over the weekend. I could make arrangements for that to happen. So I know you're on the other side of the world, but if you need help with this, I know this is one of the more challenging concepts. So if you need some help, be sure to get that help. Next thing in your notes, I want to talk about how to reduce radicals with variables. How to reduce radicals with variables. And I want you to go and get down this cube root of a to the 5th. We want to reduce this down. 3 different ways in which we could reduce it. I'm going to show you all 3, Gavin, understanding that the preferred way is going to be the 3rd way. So I'm going to show you a way I really don't like that the book shows. I'm going to show you another way the book shows that is built on the premise of what we just did, and then there's an easy way. All right, so first method is the fractional exponent method. We know that the cube root of a to the 5th could turn into a to the 5/3. And 5/3 literally is 1 and 2/3. And when we say 1 and 2/3, we literally mean 1 plus 2/3. Because after all, if you ate 1 and 2/3 pizzas, that would be 1 pizza plus 2/3 of a pizza, right? 1 and 2/3 means 1 plus 2/3, which we're adding the exponents here. And when do we add exponents? Well, we add exponents when we multiply like bases. And you understand that this has a fractional exponent which indicates a root. This doesn't, so this doesn't indicate a root. So the a to the 1st can just stay a to the 1st. This could turn into the cube root of a squared. And there's my reduced form. You can understand how this would take a very long time. Method number 2 is the factoring approach. This is the way the book shows it. I can't take the cube root of a to the 5th because a to the 5th isn't a cube, but a cubed is a cube. And a to the 5th is a cubed times a squared, because when you multiply like bases, you add the exponents. We could factor, like we do our numbers, we could factor our letters into a cube and that which isn't a cube. And of course, we know the cube root of a cubed, well, that's just a. And the cube root of a squared, well, it's just the cube root of a squared. And you'll notice that's considerably quicker. But there's an even faster method. It kind of goes hand in hand with this method of 5 divided by 3. How many times does 3 go into 5? Once, with 2 left over, right? Well, on a similar note then, you could say this. 3 goes into 5 evenly one time. But there are 2 left over. Left over where? Left over inside the radical. Left over as the radicand. Boom, I'm done. No written steps, no factoring, no fractional exponents, just writing the answer. And for a lazy mathematician like myself, that's the way to go. Let me show a few more examples that the class would have participated with me in. In fact, they did earlier today. You just don't get to see it. The cube root of x to the 6th. I'm not bitter about our technological problems, don't get me wrong. Okay, maybe slightly. My computer still won't connect to the internet, but at least I can use my Mevo now. Anyway, eventually I'm going to upload those videos for you. Cube root of x to the 6th, y squared z to the 7th. You're going to ask yourself the same question you would always ask yourself with division. How many times does this go into that? How many times does 3 go into 6? Twice. Evenly. With nothing left over. How many times does 3 go into 2? It can't. Ever. 0. So both are left over. 3 goes into 7 2 times with 1 left over. However many times it goes in evenly, that's what you write out here because you're evenly taking the root. And however many are left over, you leave over in the radical. How about this one? Write this one down. The 4th root of a to the 10th, b to the 7th, c squared. 4 goes into 10, yes, 2 times, with 2 left over. So I have 2 a's out here and 2 a's in there. 4 goes into 7. 1 time with 3 left over. And 4 goes into 2. No times. So what do I do to the c squared if 4 can't go in? Leave it exactly where it was the whole time. Hopefully that makes sense to you. If not, maybe rewatch. Now, normally we won't just have letters in our radicals. Normally there will be a numerical coefficient and the literal coefficients, constant and variables. So what do we do if there's a constant and there are variables? Well, start by factoring the number. Again, you're not asking how many times does 2 go into 8. We don't divide the radicand by the exponent or by the index. We divide exponents by index. So don't ask how many times does 2 go into 8. No. Numbers, we still factor. 8 must factor into 4 times 2. So that the 2 comes out of the 4, and we're going to leave the square root of the 2. Now, the a cubed and b to the 4th still exist. Don't lose them. But we're going to focus on the number first. Ignore everything else. Lock in on the 8. Factor it up. Take the root you can take. Leave the radical of the part you can't take. Now to the letters. 2 goes into 3 1 time with 1 left. 2 goes into 4 2 times with none left. That's all we're doing. It is that straightforward. How about this one? Write this one down. The cube root of 24 mn to the 4th. Now, if you feel you're ready to try one on your own, pause the video real quick and do it. All right, start by factoring the 24. Hopefully you knew to factor it. Right, not 4 times 6, that'd be for a square root, because 4 is a square. I need 8 because I need a cube. Mn to the 4th. And I can take the cube root of the 8, and I'm going to leave the cube root of the 3. Now, I'm not going to leave the mn to the 4th, just taking care of the number right now. I just brought the mn to the 4th down so I didn't forget it. But I focused on the numbers. Factor it, take the root, leave the irrational part. Now take care of the letters. 3 goes into 1. Right, it never does. 3 goes into 4. 1 time with 1 left. We're done. That's it. So letters are not a problem as long as you ask yourself, how many times does this go into that? However many times it goes, write it down. How many ever are left over, leave them inside. How about this one? The 5th root of 64 x to the 13th y to the 15th. The fifth root. Now, Gavin, we've got a list of square roots we know, right? Square root of 4, square root of 9, square root of 16, square root of 25, and so forth, right? We've even got a list of cube roots. Cube root of 8, cube root of 27, cube root of 64, and so on and so forth, right? We don't know a whole lot of fifth roots. We really only know one. Well, technically two. We know the fifth root of 1, but we also know the fifth root of 32 is 2. Well, sure enough, 32 is a factor. You lock in on that number, you factor it. 32 times 2, and of course keep the letters for now. Take the fifth root of 32 and leave the fifth root of the 2. Again, don't worry about the letters right now. Just focus on the number. You just brought them down so you wouldn't forget them. Factor, take root, leave your rational. Now, let's take care of the letters. 5 is into 13 with 3 left over. 5 is into 15 with none left over. And there's our answer. All right, this time I need you to do page 281, numbers 22 to 30, the even. Page 281, numbers 22 to 30, the even. Once you're finished, go on to part 3 of this video.